So today we'll be discussing about a few problems based on the distance formula. So most of your questions will be based on properties of triangles, properties of square, collinearity and equidistance. So we'll do one problem each on every concept, alright, and we will talk about their properties in detail while doing those problems. So the first problem that we are talking about here is based on the properties of triangles. So in the question, you can see that there are three coordinates given, right? There's one coordinate where the x coordinate is given as 3 and the y coordinate is given as 2. The next coordinates, x is -2, y is -3. The other one is 2, 3. Now, what are they asking? Do these points form a triangle? So for that, we need to know one of the properties of the triangle, which is a triangle is valid if sum of its two sides is greater than the third side. Now, what does this exactly mean? Let me draw a triangle and let me give A, B, C as the name of the three sides. Now, according to the statement, what they're trying to say here is that if we take the sum of B and C, it should be greater than A. And if we take the sum of A and B, this should be greater than C. And if we take the sum of C and A, it should be greater than B. So if you're summing up the sides of any two sides of the triangle, it should always be greater than the third side that you have left out. So that is one of the properties that we will be using in the numerical. So here we get back to the questions. Three coordinates given. They're asking us if these points form a triangle. So we already talked about the property of the triangle. So let us just give these three vertices, place these three vertices on the triangle. So this is my triangle. This point can be 3, 2. This can be -2, -3. This point can be 2, 3. I've just chosen it randomly. So this side right here, how do I find the distance? We know the distance formula. So we can directly take these two coordinates, apply it in the distance formula and find out the distance of this side. For now, let us just give a name for this side. So let us give it A, right? So let us find the distance of the side A. So how do we do that? We know the distance formula. So A will be equal to square root of, what is the distance formula? x2 minus x1 the whole square first, right? So here you can choose either of the coordinates as x1, y1 or x2, y2. Let me just choose this as x1, y1 and this as x2, y2, just for convenience sake. So according to the formula, x2 minus x1 the whole square, right? x2 is 3 minus x1, which is -2. So minus of -2. Always remember the number, if it is minus, then you will have to be careful with the formula as well, because the formula itself is x2 minus x1 and the number here is negative. So you will have to be careful with the formula. 3 minus of -2. Alright. So we are done with x2 minus x1. The whole square. What is the formula next? Plus y2 minus y1, right? So what is y2 here? 2 minus y1 and y1 is -3. The whole square These are all under the square root. Now let us calculate it further. 3 minus of minus 2. So minus of minus is nothing but plus. So it will be 3 plus 2. So what is 3 plus 2? 5. So this will become 5 square. Plus 2 minus of minus 3. Now what is minus multiplied by a minus? It's a plus. So that is why it will be 2 plus 3. So what is 2 plus 3? It's again 5. So it will be 5 square. So we know that 5 square is 25. So it will be 25 plus 25. What is 25 plus 25? It is 50. So this will be square root of 50. So we know that side A is square root of 50. We'll have to do the same thing for the other two sides. So let me name the other two sides as B and C. So let us find out the distance for B and C. So to calculate the distance of B, what are the coordinates that you will choose? It is these two coordinates, right? Because B lies here and it is touching these two vertices. That is why we choose these two coordinates. So here we have taken x2, y2 as 3, 2. Let us just take x1, y1 as 2, 3. Convenience sake, just because we are using the formula. So B will be equal to, again, apply the distance formula, which is square root of x2 minus x1. So x2 is 3, x1 is 2. So it will be 3 minus 2. So x2 minus x1 the whole square plus y2 which is 2 and y1 which is 3. So it will be 2 minus 3 the whole square. So that is equal to square root of, what is 3 minus 2? 1. So it will be 1 square plus, what is 2 minus 3? 2 minus 3 is minus 1. So it will be minus 1 the whole square. So you know what is 1 square? It is 1. And minus 1 square is also 1. So it will be square root of 2. Which means here this distance B is equal to square root of 2. Alright. Now we'll have to find the distance for the side C. So what do we do for C? So for C, we choose these two coordinates because C, this side, lies on these two coordinates. So you can just give any of these, place any of these as x2, y2. It's your choice. Either this can be x2, y2 or this can be x2, y2. Depends upon you. So C is equal to square root of, we've chosen 2 to be x2. So x2 minus x1. x2 is 2. x1 is minus 2. So we'll have to be careful. The formula 2 minus of x1 which is minus 2. Further the formula plus y2 minus y1. So y2 is 3 minus y1 is minus 3. So inside the bracket and then the whole square. Here as well the whole square that I forgot to put here. Just place it here under the square root. So what is minus of minus? It is plus, right? So it will be 2 plus 2 the whole square. So what is 2 plus 2? 2 plus 2 is 4. So it will be 4 square plus 3 minus of minus. So this minus of minus makes it plus. So that is why it will be 3 plus 3. So what is 3 plus 3? 6. So it will be 6 square. Now 4 square is 16 and 6 square is 36. So what do we get here? We get square root of 52 as our distance for C. So here C, the side C will be equal to square root of 52. Now we have all the three sides, right? You need to convert that square root into a fraction or an decimal point number so that it will be easier for us to deal with the numbers. So here we have square root of 50. So what is square root of 50? We'll have to calculate that. So we got square root of 50 as 7.07. Okay. Now let us calculate square root of 2. Square root of 2 is 1.414. Alright. And then square root of 52. that should be equal to 7.211. So we have all the three distance in decimal point numbers, so that will be easier for us. So according to the property, what do we know? If you add any of the two sides, it should be greater than the third side. So let us take all the possibilities here. Alright. So we have three numbers, 7.07, 1.44 and 7.211. Let us just take approximates. So 7.07 can be 7.07 itself. We will take 1.414 as just 1.41 and 7.211 as just 7.21. So let us take these two sides first. So when you add 7.07 and 1.41, what do you get? You get 848. So you get 8.48. Now is this 8.48 greater than the side that is left out, which is 7.22? Yes, that is true. 8.48 is greater than 7.2. So the first side is satisfied. Let us check for these two. Alright. So if you add up these two distances, it should be greater than this third distance. So let us do that. 1.41, which is this distance, plus 7.21. So what do we get? 1 plus 1, 2, 4, 5, 6 and 8. 8.62. So is 8.62 greater than the side that we left out, which is 7.07? That is also true. Now what is left out? These two, right? We've already done the combination of this, then the combination of this. Now let us do the combination of these two sides. So 7.07 plus 7.211. It will almost be equal to something 14.28. Now just compare this 14.28 with 1.44. Of course 14.28 is greater than 1.414. So this third condition is also satisfied. So all these conditions satisfy, and that is why these 3 points, they form a triangle, right? So this is the kind of question that they can ask you based on the property of the triangle. Now only proving that these three coordinates are a part of a triangle is not enough. Sometimes their question can be prove that these three coordinates are a part of a triangle, and also if you prove that it is a part of the triangle, then you'll also have to state what kind of a triangle it is. If it is a right angle triangle, scalene, equilateral, isosceles, whatever. So if you observe these three distances here, there is square root of 50, there is square root of 2 and there is square root of 52. Now if you try to square this square root of 50, what will you get? The square and the square root will cancel and it will give you just 50. If you do the same thing to square root of 2, which is square the square root of 2, it becomes 2. And the same thing to this part, it will become 52. So this actually reminds us of the Pythagoras theorem. Let me just prove that to you. So the three distances that we have is square root of 50, square root of 2 and square root of 52. We also know the Pythagoras theorem, where a square plus b square is equal to c square, right? If you place these three distances properly, then you can prove that the triangle that was formed previously was a right angle triangle. So what can you do? Just place square root of 50 as a, place square root of 2 as b and square root of 52 as c, right? So your c is your hypotenuse. According to the Pythagoras theorem, your c should be the hypotenuse. So in this case, it will be square root of 52, right? So let's just place all of these distances. So it will be square root of 50 the whole square plus square root of 2 the whole square. Now what we have to do is calculate this. You cannot just directly write equal to square root of 52 square. You will have to prove that it is equal to square root of 52 square. How can you do that? What is square root of 50 the whole square? The square and the root cancels and that becomes 50. The same thing happens here. The square and the root cancels and it becomes 2. So now what is 50 plus 2? That is equal to 52. Isn't that right? Isn't 52 the square of square root of 52? Right? So that is how we prove that this is a right angle triangle with this as this distance, the hypotenuse distance, as square root of 52, and the other two sides can be square root of 50 and square root of 2. Here in this case we did not use the decimal points, alright, because using the decimal points would just make it a little difficult for us to deal with all the points, right? Because there's a square here, remember? So we'll have to square it again. So instead, just use the square root. There's no harm in using the square root. It will give you the same answer anyway. What you have to find is the type of triangle, right? You don't have to deal with the decimal points numbers here. You can just deal with the square roots and get done with your answer. So your answer will be that it is a right angled triangle. So this is one of the type of questions that you can get on the properties of triangle. So we are done with the properties of triangle. The next thing is properties of square. So let's just do one of the problems on properties of a square. So what we have here is problem 2, which is based on the properties of square. So what is the problem? Show that these points are vertices of a square. So to do this problem, you need to know about the properties of square. So let us get into the properties first. So let us just draw a square. Alright. So what do you know about squares? One thing is that all the sides should be equal. That is, if the distance of this side is suppose A, alright, then the distance of this side should also be A, the distance of this side should also be A, and then the distance of this side should also be A. So all the four sides of a square have equal distance. So this is one of the properties, alright. So the first property is equal distance of sides. The second property that we'll be talking about is the diagonals. So what are diagonals? These two lines that cut out the vertices of the square while intersecting each other, that is called as a diagonal. Alright. So in a square, we know that the sides are all equal. What about the diagonals? The sides of the diagonals, the distance of the diagonals, they are also equal. But they are not the same as the sides of the square here. So this will be A, and A. But the distance of this diagonal will be something different. For example, B. So if the distance of this diagonal is B, then the distance of this diagonal will also be B. So what is the second property? It talks about the equal distance of diagonals. So keeping in mind these two properties of the square, we will solve the previous problem. So this was the problem. I've already told you about the problem and the property. So let us just draw a square first. And then place the points. So these points will have to be placed here on these vertices. So let's start placing that. Let us give this side as this vertex as 1, 7, this as 4, 2, this as minus 1, 1, and this as minus 4, 4. Now that we have placed all of these, what do we have to do? The next step always will be finding out the distance, right? That is what our main motive is, to find out the distance and then prove that all of these distances are equal, right? So that is our first property, that the sides of a square are equal. So let us find the first side. Let me just name this side as A. So I have to find the distance here. So I use the distance formula, right? So for the distance formula, I need these two coordinates because I'm trying to do the distance of A. So I will need these two coordinates. Why will I choose these two coordinates? I will not choose these two, right? I'm trying to find the side A. So that is why I'll use these two coordinates because they pass through this side. So these two. So what is the formula? Square root of the side A is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. This is all under the root, right? So let us do that for A first. So for A, it will be A equal to square root of, you can take any of these as x2 comma y2 or x1 comma y1. I'll just take this randomly x1 comma y1 and this as x2 comma y2. Let's just go in order. So this is x2 and this is x1. What is the formula? x2 minus x1. So 4 minus 1. 4 minus 1 the whole square plus y2 is 2, y1 is 7. So it will be 2 minus 7 the whole square. So 2 minus 7 the whole square. So that is all under root. So that will be equal to square root of 4 minus 1 is 3 square plus 2 minus 7. How much is 2 minus 7? It is minus 5. So minus 5 the whole square. So that will be equal to 3 square is 9. And 5 square and minus 5 square is the same. So it will be 25. So what is 25 plus 9? That will be square root of 34. So we have one of our sides here. We need to calculate the other three sides as well. So let's take this side, for example, as B. So let us calculate the distance of B. Just change your coordinate here as minus 1. It is minus 1 comma minus 1. Alright. That was just a mistake. I had placed it as minus 1 comma plus 1. It is supposed to be minus 1 comma minus 1. Okay, so let's get back to the question. So we've already found the distance of A. We need to find the distance for B. So this side I have named it as B. We have these two coordinates that we will choose and we will place these x2, y2, x1, y1 in the distance formula to get our distance. So B, which is our distance, will be equal to square root of x2, which is 4, minus x1, which is minus 1, the whole square, plus y2, which is 2, minus of y1 is supposed to be minus 1. So minus of minus 1, the whole square. So what is it equal to? Minus of minus is plus. So 4 plus 1. 4 plus 1 is 5. So it will be 5 square plus, what is minus of minus? Plus, right? So 2 plus 1 is supposed to be 3. So 3 square. So what is 5 square? 25. Plus what is 3 square? 9. And this is all under the square root. So what is 25 plus 9? It is 34. So the distance of B also is 34. Now remember, don't just stop at finding two distances and say that yes, it is a square. You will have to do it for all the sides. Because what if these two were same and these two were different? Or maybe these three were same and this was different. So you'll have to be careful and do for all the sides. You cannot just be like, I give up just by doing two sides. It is enough to prove that it is a square. No. All the four sides are important. So now that we have done B, we will move to C. So for C, we'll use the distance formula again using these two coordinates. Alright. So it is minus 4 comma 4 and minus 1 comma minus 1. x1, y1 is already here. Let us place x2 comma y2 here. So these two in the distance formula, C is equal to square root of, what is x2? Minus 4. minus of x1, which is minus 1. Be careful with the negatives, alright, plus y2, which is 4, minus of y1, which is minus 1, the whole square. Be careful with the brackets and the negatives and the square root. Don't forget any of it. So this will be equal to, what is minus of minus? Plus. So we have minus 4 plus 1, which is equal to minus 3. So this will be equal to minus 3 square. Plus 4 minus of minus 1. So 4 minus of minus is plus 1. So 4 plus 1 is equal to 5 square. So minus 3 square is the same as 3 square, which is 9. So we have 9 plus 5 square is 25. So what is 25 plus 9? It is equal to square root of 34. So we've got the distance of A, B and C to be equal. Now we just need the last one, which is D. So for this D, we choose these two coordinates, 1, 7 and minus 4, 4, and apply the distance formula for these two coordinates to see if this distance as well is equal. If this distance is equal, then the first property is proved. So for that, we'll have D is equal to square root of x2, which is minus 4 in this case. So minus 4 minus 1 the whole square, plus y2, which is 4, minus y1, which is 7, the whole square. Then we have minus 4 minus 1. What is minus 4 minus 1? Minus 5. So minus 5 square plus, what is 4 minus 7? It is minus 3. So this will be minus 3 square. So minus 5 square is same as 5 square, which is 25. And 3 square and minus 3 square also are the same. So that will be 9 under the square root. So 25 plus 9 is equal to square root of 34. Now by looking at all the distances, you can say that the first property about the square is right according to these coordinates given. So all the sides are equal, which is the next property that we'll also have to prove. That is that the diagonals are also equal. Now for these diagonals, we need to apply the distance formula for these two coordinates, because this is the diagonal. So we need for these two coordinates and then the other diagonal, which is these two coordinates. So for these two coordinates, let us apply the distance formula. And according to the property, the diagonal is supposed to be equal. So both these diagonals should have the same distance. So let us do that. So for the first case, what do we have? This diagonal. So this diagonal has coordinates as 1, 7 and minus 1, 1. Sorry, minus 1, minus 1. So we apply the distance formula there. So let us take this as the diagonal E. Alright. So this diagonal E is equal to square root of, let us take any of these coordinates as the coordinate x2, y2. So let us take this as x2, y2. Then we have x2, which is minus 1. So x2 minus of x1, which is 1, the whole square, plus, what is y2 here? Y2 is minus 1. So again we have minus 1 plus, y2 minus, so that should be minus. So y2, which is minus 1, y2 minus y1, which is 7. So x2 minus x1 the whole square plus y2 minus y1 the whole square. So that will be equal to minus 1 and minus 1 is minus 2. So it will be minus 2 square plus, what is minus 1 minus 7? It is minus 8. So minus 8 square. So minus 2 square is the same as plus 2 square. So it will be 4 plus 8 square and minus 8 square also is the same. So 64. So what is this equal to? Square root of 68. So we have found the distance for one of the diagonals. Let us find the distance of this diagonal. If this distance is same as 68, then we will prove that these 4 coordinates given to these vertices of the square makes it a square. So let us give the name as f for the other diagonal, and let us calculate the distance. F is equal to square root of x2. x2, let us just take, this is x1 and this is x2. So x2 is minus 4 minus x1, which is 4, the whole square, plus y2, which is 4, and minus y1, which is 2, the whole square. So minus 4 and minus 4 makes it minus 8. So 8 minus 8 square plus 4 minus 2 is 2 square. Again, minus 8 square plus 8 square has the same value. So 64 plus 2 square is 4. This gives us square root of 68. So we have both these diagonals as square root of 68. And all the sides are also equal. So these 4 vertices that are given for this square proves, using these properties, that it is true in this case. So here a was equal to square root of 34, b was equal to square root of 34, c was equal to square root of 34, d was equal to square root of 34. So all the sides were equal. And then we had diagonals f equal to square root of 68 and e equal to square root of 68. So these two properties make up a square, and that is what we learned in this problem. So now we can strike out the property of square, because we finished one of the problems based on it.